Hi, my name is Chris Wendt. I'm the Group Program Manager for Microsoft Translator, and I'm here with Kelly Altum, also a Program Manager on the Translator team. We're here to talk about new functionality for the Microsoft Translator service, which offers you speech translation close to real time. This is the same service that is being used by Skype Translator, used by millions of people, having translated millions of conversations between two people who do not speak the same language. We'll first go through a little bit of basics. Then Kelly will walk us through the code of an iOS application using the speech translation service. And then we'll have a demo and a short conversation of what the service does. The Microsoft Translator service has been around for a while, offering text translation between 50 languages. We are now adding speech translation functionality. It is offered as a streaming service. You feed it a stream of audio and you receive the recognition and the translation and translated audio if you want it back to process in your application as you like it. It's competitively priced, and it currently supports 8 languages, speech input for 8 languages, and text output for 50 languages. This is an optimized service for human-to-human conversation. So that's different from any services where you talk with a machine. The service is specifically designed to clean up the artifacts of human spoken language and make it translatable. It's provided as a WebSocket API, and you feed it a stream of PCM encoded audio, and you receive back the text of any partial recognition, the translation of that partial recognition, and then you receive the final recognition when the speaker makes a little pause, and the translation of that final recognition. If you want to, you can also receive the audio to play to the audience as you like. Our demo will not include the translated audio, but you get it as part of the stream that you receive back. Here's an example of the WebSocket call with parameters. You can see you set the languages, you set the voice that you want to hear, and you say whether you want to receive partials or not. For a bidirectional conversation, you just open 2 of these. So the translation service has been around for a while, offering, as I said, text translation between 50 languages. There are also related methods to feed corrections into a translation memory and use these corrections to train customized translation systems for your organization that translate your organization's terms and terminology and commonly used phrases better than the generic translation service would do that. Also offers array methods of all of the functionality, so you can save on the timing for round trips. Kelly will now walk us through a sample application that's also posted on GitHub.
I'm going to step through the typical flow of a speech API application, and then I'm going to walk through some code from an iOS app that we did as a demo app. The iOS app will be available on GitHub, so you don't have to pay a lot of attention or copy any of the code. It'll all be available for you on GitHub as a sample app. The first thing you do when you set up an app is you set up the audio for the app. You can have the audio coming in from a microphone, or you can have it coming in from a file or from a video. Then you need to get an OAuth token to access the service, and then you send that token via a WebSocket to the Microsoft Translator service and get connected. As soon as you connect, you set up a header, and then you begin sending audio. As soon as you start sending audio, you also start receiving back over the WebSocket text and data is the audio. And then once you get the audio back, you can display the text to the user and play the audio for the user, and then disconnect when you're done. Okay. So this is an application that we created, and this application is an iOS app running on an iPad. And the scenario is you walk into a tourist information center, and you want to ask a question, but you don't speak the language. So you pick the language that you speak on the iPad, and then you speak into it, and the other person who's going to answer your question has an iPad. They see the translation in their language, and they answer you, and then you see it on yours. So you pick the language, You speak into it, and there's the translation that comes back after a few seconds. The person can read it in their language, and then they can answer your question. So let's look at the code. The first thing you need to do is you need to get an OAuth token. And there's 4 parameters that you need to send in: the client ID, the client secret, grant type, and scope. The secret and the ID you get at the time that you set up the account with Microsoft Translator. Then you need to encode those strings and prepare them to be part of a URL. You create the parameters for the URL, insert the parameters, and then you set up an NSMutable URL request with the endpoint, and you set it as a post, and you put the URL with the endpoint into the HTTP body. Then you create an NSURL session task with a completion block, and then do a do, try, catch, and extract out of the data from when you deserialize the JSON, you extract out the access token. Now you have to put the word bearer with a space in front of the access token, and once you have that, then you're ready to connect, and we call the connect WebSocket method. The task resume is what kicks off the task to begin with. So now we're in the connect WebSocket method, and we want to send the parameters to the service. We're interested in voice. We have a to language and a from language. We also are going to get partials, and text-to-speech means that we get the audio back. The partials are very interesting because you can see the process of voice recognition and translation as it's happening. It builds up the entire sentence that the system is working on at the time. Now we're going to create a WebSocket instance, and this comes from the Starscream iOS that we got from GitHub to help us with the WebSocket connections. We have the endpoint, we stick the parameters in there, and then we add a few things into the header, the token itself, so we can get access. There's also a thing called the correlation ID. And the correlation ID is used when you have multiple conversations going. You can identify the conversation from the correlation ID. We have some delegate methods that we need, and in case the socket is connected, we want to disconnect it before we connect again. So we're going to connect. Now we are in one of the delegate methods called WebSocket did connect. This is where you want to start sending data to the service. So we're going to create an AV audio PCM buffer, and then we're going to do a do, try, catch. Now this is to open the file. At this point, what we're doing is we're taking data out of an audio file, but we could just as easy take this from the microphone or take it from the video. So once we have the file, we're going to format the file so that it's ready to be used. We're going to do another do, try, catch to put the audio data into the buffer. And then we need to set up a pointer and get the length, and then we put all of that data into an NS data audio data, which is what we will send to the service. Now before we send to the service, we have to configure the header. So we're doing a sample rate of 16K and 32K, and I'll show you the method in a second that sets up the header. And then this socket write data is where we send the header to the service. We're going to take the data that we have and we're going to put it into 3K chunks. And then once we chunk up the audio, we're going to write it to the service. Now at this point, we're going to start getting data back from the service. Now there's one thing that we need to do to let the system know that we're done talking, that the audio is done talking. So there's a concept of an utterance. So we need to know when the utterance stops. So to do that, we're going to send about 2 seconds of silence. And we're going to send that to let the service know, okay, you can go ahead and start processing because I'm done talking. And then we're going to write it to the service. So this is what the header looks like. This is a WAV file header. It's really important to configure the header yourself to make sure that you get it just the way the service wants it. We have the sample rate in there, we have the byte rate in there, we have the bit depth, we have the number of channels, variety of information. But once the header is right, then the service can move forward. Now that we're sending data, we also want to process the data that's coming back at the same time we're sending it because it is a WebSocket. So we're interested in 3 pieces of data. We're interested in the message type, the recognition, and the translation. There's a lot of other data that comes back to the service, but right now we're just interested in these 3 pieces of data. So what we want to do is deserialize the JSON that comes back in the message, and then we want to extract out the message type to find out if it's a final or a partial. Once we know that it's a final, we want to grab the translated string, and we want to get the voice recognized string. And once we have those 2, we're going to display the recognized text to the person who asked the question. We're going to post the translation to a web service so that the other iPad can pick it up. And then we're going to disconnect the socket. Now, if we were processing the data, we're not in this app right now, but if we were processing the audio data, it might look something like this. So when you get a chunk of audio data back from the service from the WebSocket did receive data method, what you do is you check the first bit of the chunk to see if that is the last bit. It's called the fin bit. And the fin bit will let you know that you got all of the data that you need to get back. And then you just put all the data together and play the audio. And as I said before, all of this data will be available, these sample apps will be available on GitHub along with some sample apps for C# and Python.
Kelly, thank you for walking us through this. I have a couple of questions of the functionality of that, about the functionality of that program. You said that you need to get an access token in order to use the translation service. How long is that token valid?
The token is good for 10 minutes. And one of the parameters that comes back tells you how many seconds it is. And you can either monitor that, and when you need to get it, to renew it, make a renew call, or you can just, every time you need a new request, just get a new token.
Okay, that makes sense. In the architecture, why did you choose to use WebSocket instead of HTTP 2?
Well, HTTP 2 is primarily used for text, bidirectional text transfer. And we needed to do text and data, and the WebSocket is really the best for text and data transfers, bidirectional.
What happens if you forget to close the WebSocket connection and you just start a new?
Well, we're not doing this service for free, so there is some charging going on. And if you leave a WebSocket open, we don't know if you are meant to leave it open or if you just decided to forget to close it. So we're going to continue charging you by the second. And so it's very important to make sure that when the session is done, you disconnect the socket.
Okay, saves me money.
Yeah.
As you wrote the application, did you choose to use the partials or not? Why would I use the partial results if they are not reliable?
Yeah, you know, the partials are really cool because you get to see the system as it's kind of, for lack of a better term, thinking about how to recognize this text and translate it. And so that's really interesting to see. But one of the cool things about that is you can send that to the person so that they know that the system is processing what they're talking about and they can see it. So you can, you know, in an iOS world, you can put a little spinning donut up there to let them know that the system is working on something. But sending back the partials is a cool way to do that. So Chris, what's up next for the Translator APIs?
Okay, so we are adding new languages as we go. We have been adding new languages every couple of months. We are going to continue that pace. So going from the current set of 8 to more, to 12, 16, and so on. And we also improve the quality continuously. This is automatic speech recognition, automatic translation. Neither of them work 100% reliably all the time, giving you exactly what you said. So there is continuous work to do to improve the quality of the service. Then we are also going to enrich the text translation methods for translation and transliteration to give you far more options and capabilities in the text translation space.
And how long does it take to add a new language?
So the most labor involved in adding a new language is collecting training material. That's the audio and transcript in the appropriate domains that you want to cover. And that takes some time, takes money and effort. That's why we can do that only every couple of months, adding a new language.
So Skype Translator has been using this for a long time. How many conversations do you think have happened with Skype Translator in the languages that we support?
We have translated many millions of conversations since we launched in fact in December. And the conversations are between people who would normally not be able to talk to each other, right? Because they don't share a common language. So we feel we have really advanced the state of international communication, breaking down language barriers.
Great. So Microsoft has been working on translation for a long time, haven't they? Since the early 2000s?
Well, in fact, the natural language processing group that the translator team grew out of has been one of the first two teams that were established when Microsoft Research was founded in 1991.
Wow.
I haven't been with it for that long yet, but the foundation has been laid in 91.
Great. That's a long time. Okay, we're going to do a demonstration of the iOS app. Chris is going to speak in German and I'm going to speak in English. And imagine this is a tourist information center and Chris walks in and wants to ask a question.
I'm choosing my language here. Hallo, können Sie mir den Weg zur nächsten Bahnstation zeigen?
Now the system is translating, and once it gets translated and sent back to his iPad, it also gets sent to my iPad and I can see it. And he's asking me where the nearest train station is. So I'm going to answer him. Yes, I can tell you where the train station is. Go out of the building, turn right, and go down 200 meters. Now it's being translated, and it's going to show up on my screen in my voice recognition, and in Chris's screen it shows up in German.
Vielen Dank, das werde ich machen.
You're welcome. You're welcome. Have a good day. And that's how quick it is. After just a couple of seconds, the recognition comes back and the full screen comes back and Chris knows where to go, and I've done my job as a tourist information center.
Thanks, Kelly, for walking us through that. That was very informative. If you have more questions about this service, visit us on the web, microsoft.com/translator, or browse the samples that we have on GitHub.
And if you're at Build, come and see us in our booth, and we have some other demonstrations we can show you. Thanks.